In the next short series of videos, we're going to be looking in more detail at the effects of zeros at 0 Hz, zeros at other frequencies, and poles. We'll start off by looking at zeros at 0 Hz. Remember that in our big general form for the frequency response, the zeros at 0 Hz occurred here. We have the other zeros up here and the other poles down here. But it's just that term that I'm going to be concerned with at the moment. J omega, the zeros at 0 Hz. If I take the modulus of this expression and express it in terms of decibels, then the effect of this term here is going to be 20 log 10 of the modulus of j omega. Well, the modulus of j omega, that's just the distance from the origin to the complex number j omega. That's just going to be omega. So I could write that as 20 log 10 of omega. And that's its contribution to the amplitude response expressed in decibels. If I plot this on a graph, have the y-axis as the contribution in decibels, then I would end up with a graph like this. At 1 radian per second, it passes through the 0 dB point because the logarithm of 1 is 0. Otherwise, it's a straight line if I plot it in terms of the logarithm of the frequency on the x-axis. And it's a straight line of the form y equals mx. That's just my x term there, with the gradient of 20. So the effect of a zero at 0 Hz is to cause the amplitude response to rise at 20 dBs per decade, per factor of 10 in frequency. In terms of phase, j omega is going to be there, on the imaginary axis. So it's going to introduce a phase term of 90 degrees. And it's a positive 90 degrees. If you remember, the phase response is the output phase minus the input phase. That is plus 90 degrees here, which means that the output is going to be 90 degrees ahead in phase of the input. If the output was doing something like this, then the input would be 90 degrees behind it, and therefore doing something like this. About the only other thing I need to do in this video is to note that I will refer to these gradients in terms of decibels per decade. So this one, we're going up by 20 dBs for every decade, every factor of 10 increase in frequency. I would write that as plus 20 dBs per decade. That's all I need to say about zeros at 0 Hz. Next time, we'll look at zeros that are not at 0 Hz.